Thanks for the invitation. It's really nice to see so many folks here interested in talking about soil and plants and how we can do better with our management. My name is Youngquist. I work with University of Wyoming Extension. I'm based in Washakie County, and I specialize in soil and have been doing a lot of work along the lines of cover crops and sustainability and regenerative agriculture and all those things you might be interested in. So what I would like to share is just a little bit of introduction to some of these maybe principles and concepts and a little bit of the biology. I think it's helpful to get all on the same page and understand some of the basics as we go along and talk about land management. So I think you all have a copy of this presentation that was available there when you came in. And many of you have, I'm sure, are familiar with the soil health principles, the 5 soil health principles. That if you've done any reading or following along on some of the different programs or speakers, you'll hear the reference to these a lot. Minimizing disturbance is really critical. Maximizing soil cover, so that's either with perennials or annuals. Integrating livestock. Continuous living roots, so keeping living plants in the soil as long as possible year-round within the constraints of our seasons, and then increasing biodiversity. So those are your 5 soil health principles. I think many of you are familiar with that, and that I think helps provide a framework for what we're looking at. The other things I think it's worth sharing is that really as land managers and as soil managers, there's a lot of value in just being a very, very keen observer. Why are we seeing what we're seeing, and what are the patterns across our landscapes and across our soil, and how are they changing over time? And so being a very keen observer and really having a deep understanding of the biological principles. So understanding the basic biology and chemistry that's driving our system, I think is really helpful. In what I might call modern or conventional or high input agriculture, we're really good at managing chemical inputs. By that I mean fertilizer and pesticides and synthetic inputs, and we're really good at managing the physics of the soil. What type of implement do we pull across the field to get the results that we want, right? And so that third piece of the puzzle is the biology. And so how do we become more keen observers of our landscape, get a better understanding of the biological principles and processes, and balance that out, right? So that was just something I would encourage you to think about today and through your time as you're managing land and soil. The other thing that's a very popular topic or concept of late is this concept of regenerative agriculture. I suspect some of you have heard of that. A big buzzword for a long time was sustainable agriculture. Now the popular press and a lot of consumers and producers are really interested in this concept of regenerative agriculture. I'm not sure there's a really one definition, but one way I think that's helpful for me to think about it, it's first of all very related to soil health principles. So if you're building your soil, you could say you're regenerating your soil, right, or using regenerative practices. And I think one thing that I think is helpful is, can we make things better on our land with careful management of soil and water and livestock? And can we use livestock especially as a tool to heal the land and to heal the soil? And I think that maybe is the next step, whereas the concept of sustainability might be, can we do less bad? Whereas with regeneration, can we use that as a framework to do more good? So that's something that I would leave you with. Of course, everyone's going to have a different definition, but that's some things I've been thinking about. I talked about understanding basic biological principles. Probably the first and biggest one to understand is the carbon cycle, right? How do we get carbon out of the atmosphere and into the soil? And there's a lot of excitement around that, around carbon markets, but just in terms of the basic biological principles that drive the soil system is getting carbon out of the air and into the soil through the basic process of photosynthesis. So that takes you back to high school biology, I think. Here's a little reminder here: carbon dioxide and water, the plant converts it with the light energy over to glucose and oxygen. And so that will put our carbon into the soil, into our soil organic matter. And hopefully we can keep it there. So get more carbon into the soil faster and keep it there longer. That would be your charge in terms of managing soil, right? And how is it lost? It's lost through tillage. So as we till the soil, the microbes that are working and living in the soil, primarily the bacteria, they're aerobes. They use oxygen, so they get a big flush of oxygen. They get really hungry. They eat all that organic matter, and in that process, they put that carbon that was in the soil back into the air as carbon dioxide. So that's where the tillage can affect the carbon cycle. And then, of course, extraction of fossil fuels, right? That's carbon, and so that extraction of fossil fuels from the system and back into the air. So there's a few reminders there about the carbon cycle and just understanding that basic process and how it's driven by biology, primarily bacteria, fungi, nematodes, algae, protozoa, all the little creatures we cannot see, right? You may have heard them referred to as your micro herd. So they are working very hard for you. You want to keep them fed and protected and cared for. On the second page here, you have a table that illustrates the relative number and biomass of microbial species I think this is a really good reminder about really how much is going on in that soil, and it is your microherd, and you are hopefully managing it for maximum health and production, right? So on the low end, you're looking at almost an entire cow per acre, and on the high end, you're looking at maybe 10 cows per acre in terms of living biomass in the soil, right? And that's going to vary, of course, based on many things. There's going to be less in a dryland system, perhaps more in an irrigated system. As your soil organic matter and your carbon increases over time, hopefully your microherd will increase, and the work they do for you, right? That's where the diversity comes in. When we think about above ground ecosystems, we get invasive species or we get out of balance. Our predator-prey relationships, whether on an insect or a large mammal scale, they get out of balance, right? Same thing can happen here in the microbial ecology. So we want to have a balanced system with high diversity to promote plant health and reduce plant disease, etc., and decomposition. So the other thing I talked a little bit about being a really keen observer. We'll get out on some of these fields and get out the shovel and look at some of the soil across the landscape. When you're at your place, look at your landscape and watch for patterns. Fence lines are a really great thing to look at because often the fence lines are getting the same amount of water, potentially fertilizer inputs if you're fertilizing, but they're not getting the same level of disturbance or tillage or high livestock traffic. And so sometimes you can really see what the potential for your soil is if you look at your fence lines or look at some of the areas on the edges of your fields that are less disturbed. The other thing that's really great to look at soil is when you're putting in maybe retrenching something, putting in a new water line, or maybe there's a road cut somewhere, or somewhere there's some disturbance. That's where this picture came from here. This was a water line that was going in across a pasture in the Worland area. And the reason I like this picture is you can see the soil building that's happening as the carbon is coming out of the atmosphere into the plants, into their roots, and then into the soil. And what you can see on that picture on the right, that's an alfalfa root. And if you look closely, you can see the soil right around the alfalfa root is much more darker, and it's got some aggregation, and it looks very different from the surrounding soil. And that is because that plant is taking carbon out of the atmosphere, putting it into sugars and into plant biomass, and it's secreting it out through the roots and specifically feeding the microbes in the soil that it wants to have near its roots. It's really an amazing system we know very little about so far. We're learning a lot. So you can actually see that process happening in the soil, and that I think is a really interesting thing to be able to observe. So that plant is taking the carbon out of the air, putting it into the soil, and feeding the microbes that it wants around its roots to be healthy and to get the nutrients it needs. I talked a little bit about the tillage and the disturbance and the fact that most of our soil microbes are aerobic, meaning they require oxygen like we do. And so as they break down the organic material, they use that carbon and then they release some carbon back up into the atmosphere. And that's the same process that's happening in composting, for example, as well. And I'd also like to remind you, if we think about it from this framework of regenerative agriculture, if we think about humans as a keystone species and we have the opportunity to do more, to do better by the land and by managing water and plants and animals, right? We really still cannot do better than the biological system that is nature, right? And so through reducing our disturbance, through adding our carbon and other inputs, we can really see that change over time, and we really can get that biology to work with us. If you look at this map here of the soil organic carbon levels in Wyoming, you'll see an interesting pattern, probably not a surprise to you. On this side of the mountains, we tend to have higher soil organic matter in our native soils than we do in the basin where I live, where we're doing a lot of sugar beets and barley there. And any guesses on why that might be? Some of you probably already know this. Why our native soils here on this side of the mountains tend to be higher in organic matter? Precip. And precip does what? It rains more, which means more grass grows, which means more carbon comes out of the air, which means more carbon goes into the plants, and more carbon goes into the soil. And soil organic matter is about 45% carbon. So that's the process that's happening. That's why as you move further east and you get into the short grass prairie, the mixed grass prairie, the tall grass prairie, more precipitation, that gets you into the corn belt, those deep, fertile, mollisol soils that we're still growing corn on, right? So that is just understanding how the precipitation affects our different soil types. And if we look at the bighorns, for example, and we look at those highly productive grasslands, we put a lot of cows and sheep on in the summer. Again, more precipitation, more grass growth in many of those areas, more carbon in the soil. Higher organic matter means you also store moisture in the soil longer, and over time can slowly release some nutrients back to the plants. So then that's why if you're a gardener, you add compost and manure and various organic materials to your garden soil, right? Build that soil organic matter, hold that moisture longer, provide a slow release nutrient source for your plants. So just there's a soil map here. The last picture here is a soil map of Wyoming. It shows some patterns. I think I would leave you with that is know your soil. I think you know the genetics on your cattle. You know what they do well, how they thrive, when they need, what they need and when. And I would encourage you to really know your soil to that extent as well. Know the differences across your landscape. Be a keen observer of that, and really manage the microbes in your soil, and manage the carbon in your soil, and manage the health of your soil, and really get to know it across your own landscape. So I would leave you with that. If there's any questions, I'd be happy to answer that. I will go along on the tour, so I look forward to visiting with all of you. But I guess I would leave you with that as really being a keen observer of your own landscapes, and really having a good understanding of the biological principles that drive the system.